everyone. So let us continue what we learned so far. We talked about the Cartesian plane. We introduced the Cartesian plane. Another name for it is rectangular plane or coordinate plane. Or XY plane, they have the same meaning. It includes X axis and the Y axis. And we have a bunch of points in this XY plane, rectangular plane, and so on. So we're going to talk about relations before we jump into functions. Relation is a collection of points, Another name for points, ordered pairs. In XY plane. So for example, you have relation like R equals to the set of points 1 and 2, 3 and 4, 5 and 6. For any relation, we can define the domain. Domain of the relation is the collection of all first coordinates For example, in this case, the domain of this relation is the collection of the set of, this is representing the set 1, 3, and 5. So you're going to list 1, 3, and 5. And also for any relation, you can define the range of that relation. So range of that relation is the set of all second coordinates. Second coordinates. For example, the range for this relation is equal to, well, 2, 4, and 6. 2, 4, and 6. So you have a relation. Before you define a function, you define a relation, then the domain of that relation, then the range of that relation. Of course, you can visualize your relation using XY plane. In this case, here you have your x-axis, your y-axis, and some more numbers on x and y. So the maximum value for x is 5, 1, 2, 3, 4, 5. The maximum value for y is 6. You get 1, 2, 3, 4, 5, and 6. Well, how do we represent this relation? 1 and 2. 1 and 2. This is the very first point on the graph of this relation. The second point, the second order here is 3 and 4. 3 and 4 units up. And then the third point is 5 and 6, 5, and 6 points up. So this is the graph of this relation. We are not allowed to connect these dots because this relation is discontinuous. It's not continuous. So this is the graph of this relation. This relation with some dots, 3 dots as the graph. This is your graph. The graph is just some dots. Very well. So this is a relation. After a relation, you're going to talk about a function. So A function is a relation, definitely. So a function is a relation. What's the meaning of that? It means that it is a collection of points or collection of points that passes vertical line test, vertical line test. So this is the easiest definition of a function. If you have the graph of the function, you can check to see if it passes vertical line test or not. If you have a relation, you can check to see if it passes vertical line test or not. So again, for a function, since it's a relation, we can define the domain and the range. For any function, we can define the domain and the range. Let's go over one example and try to visualize the function that we have. Let's take a look at 1.2. We are on page 1. And I'm using this example. The example that I have is y equals to negative 3x plus 7. Okay, there you go. What I want to do, I want to graph this guy, define the domain and define the range for it. So our goal is to graph y equals to negative 3x plus 7, then find the domain and range. Okay, perfect. How do we graph this guy? The easiest way to graph a function is using the method of point plotting. What is that method? We're going to use a small table. We form a table like this. Here you have your x on the left, and here you have your y on the right. What is y? Y has a definition, negative 3x plus 7. Then we start plug in at least 2 points for a linear function. Then plug at least 2 points, at least 2 values for x, more appropriately 2 numbers for x. After plug in values for x, you need to evaluate your y, then you get 2 ordered pairs, at least 2 ordered pairs. So here you have a linear function. Let us plug in 0 for x. If x is equal to 0, your y is equal to negative 3 times 0 plus 7. Well, 0 and any number, the multiplication is always 0. What's left? Y equals to 7. So your y is equal to 7. What's the meaning of that? It means that the point 0 and 7 is on the graph. Let's plug in another number. Like what? Like 1. So y is equal to -3 times 1 plus 7. -3 times 1 is -3 plus 7 is 4. Well, we say that point with first coordinate 1, second coordinate 4 is on the graph. 1 and 4 is on the graph. So we have 2 points. For a linear function, 2 points is enough. So here we have 2 points, 0 and 7, your x-axis, your y-axis, and let's label these. So here you have 8, 4, 0 and 7, starting from the origin, moving 7 units up, 0 and 7, and then here you have 1 and 4, 1 and 4, this is your second point. And then as you can see, if you connect these 2 points, you have your graph of this function. Remember that we are allowed to connect these 2 points by a line. Why is that? Because I can freely take values for x. X can be a half, x can be radical 2, x can be pi. You're allowed to take any value on the horizontal line on the x-axis and plug that into the definition of your function and get some value for your y. So what's the meaning of that? It means that the domain, which is all values on x-axis, is R. Let me write it here. Domain is R, bolded R, representing negative infinity to positive infinity. So you can just use shading method as well. For your domain, you can take this graph and look at the shade of the graph on x-axis. Here, from the graph to the x-axis, all values on x-axis are taken. They are part of the domain. Since this graph continues, it means that you can continue this process. And from this side, from the graph, the shade on x-axis, it includes all values. So this is your domain. If I ask you to shade the domain, you say that, hey, the domain is all x-axis, which is R, negative infinity to positive infinity. Well, since if you plug in any value for x, our y value is also a real number, it means that the range is also R. R, negative infinity to positive infinity. So in general, note that for any linear function, it doesn't matter if it's increasing or decreasing, y equals to mx plus b, the domain, if it's not restricted, it's always R, bolded R, and the domain range also is R. So when you're talking about a linear function, the domain and range, if it's not restricted in the question, naturally you think about R and R. Very well. Great questions were asked. How do we know this guy is a linear function? This is the definition of a linear function. For a linear function, you have y isolated on one side. Any linear function. You have your y isolated. Isolate y on one side. And on the other side, the exponent, the highest exponent of your x is just 1. So x has the highest exponent 1. So you say that, hey, I have a linear function, or you can memorize this relation between y and mx plus b. Whenever you see something like this, you say that, hey, I have a linear function. Here you have y isolated on one side is equal to, well, I have a number multiplied by x, and x has exponent 1 plus a constant. So this is your coefficient, the coefficient of x, and this is just a constant. That's how we know we are dealing with a linear function. Well, for the domain, first of all, how do we define the domain? The domain is the collection of x values that if you plug into the function is defined for those x values. So let me erase this part of the board and rewrite it for you. So another note for you. The domain is the collection of acceptable x values. So what do they mean, acceptable x values? It means that if I take that x and plug that into this relation, my y is not an error. It means that I'm dealing with a real number. So for this relation, I have y equals to negative 3x plus 7. So acceptable x values. You have to think about it intuitively. Can I plug in 0 here? Of course, if I plug in 0, I get negative 3 times 0 plus 7. It's a number. So my y is a number. If x is equal to 0, then y is a real number. If x is a half, you can use your calculator and easily calculate this. A half times negative 3 plus 7, then y is a number. What if I plug in 100, negative 100? If I plug in x to be negative 100, then negative 3 times negative 100 plus 7 is another number. Then y is a number. So what's the meaning of that? I can continue this process. There is no x that I should eliminate. All x values are acceptable. So domain is all x values. But where does this come from? These x values are coming from the real line, 2 and the rest of these numbers. From left to the right, you have real numbers. And all of the fractions are involved, radicals are involved. So the domain is R itself, or from negative infinity to positive infinity. Well, how do we define the range? So for the range is all y values. Okay, all y values. So my x is 0, y is a number. My x is a half, y is a number. My x is negative 100, my y is a number. My x is pi, my y is a number. My x is square root of 5, my y is a number. You can easily use your calculator. If you use your calculator, you can calculate all of these values. So what's the meaning of that? For whatever I plug into this function, I get a y value which is on this line, on the vertical line. So what's the meaning of that? It means that the range is all real numbers or all numbers. So it is equal to r, bolded r, or negative infinity to positive infinity. Very well. Give us another example. Let's move on to page 2. Let's see, I'm looking for a linear function here. Okay, this is good as well. So y equals to 10x minus 7. We're still on page 1. So your y is equal to 10x minus 7. Very well. First of all, this guy is a linear function. This is a linear function. Why is that? Because it is similar to y equals to mx plus b. Here you have the degree or the exponent of x equals to 1, and this is the highest degree, and you have a coefficient which is 10, and you have just a constant which is negative 7. So we have a linear function. The degree, we say that is 1. The degree is 1. What's the degree? The degree is the highest exponent of x, which is the highest exponent of x. Very well. So how do we graph this? Let us graph it. Again, the easiest way to graph it is using a table. Let us use our table. So again, since this guy is linear, 2 points enough. So here we have your x and you have your y. This is y equals to 10 times x minus 7. Remember that when you have an expression like this, multiplication comes first. So when you plug in numbers, you have to multiply it first. So choose any number that you like. Remember that here you have a linear function. It means that you can freely choose any x value. Okay, suppose x is equal to 0. When x is equal to 0, my y is equal to 10 times 0 minus 7. So 10 times 0 is just 0. 0 times any number is 0. What's left? Negative 7 is left. So what's the meaning of that? It means that point with first coordinate 0, second coordinate negative 7 is on the graph. Again, remember that we have the linear function here. We need 2 points. Let us plug in another number. Let us plug in 1, for example. If I plug in 1, then I have y equals to 10 times 1 minus 7. Well, 10 times 1 is just 10. So you get 10 minus 7, which is equal to 3. What's the meaning of that? It means that the point with first coordinate 1 and second coordinate 3 is on the graph. 1 and 3 is on the graph. Very well. So let us graph it. So let's see, 0 and negative 7, our x-axis, our y-axis. So here you have -8. Suppose you have your 8, 4, -4. And then here you have another 4, then -4. So the very first point is 0 for x and -7 for y. 0 and -7. This guy is here. The second point, 1 and 3. 1 unit on the horizontal axis and 3 units up. 1 and 3. Let us connect these together. Well, if I connect these 2 points together, then this is the graph of my linear function, which is an increasing line. So, increasing line. We read the graphs from left to right. Always remember that. From left to right, it is uphill. Okay, so far so good. I have the visualization, the graph of this linear function. What's the domain? Okay, again, intuitively. Think about it intuitively first. To find the domain, domain is the collection of acceptable x values. X values. What x values are acceptable? So you should think, can I plug in any x value here? Is it possible? Do I get an error in calculation or not? So take a look at your relation. You have y equals to 10x minus 7. I can plug in 0. If x is 0, then we can calculate y. It's not an error. If x is equal to, for example, -1/4, then the same, we can calculate y. If x is equal to -√6, you can plug that in here, use your calculator and calculate it. Then we can calculate y. You can continue this process. You can pick any x value that you like, then plug that into your calculator and get your y. What's the meaning of that? It means that any number on the real line or x-axis, remember that the domain is the collection of acceptable x values. On the horizontal line, x-axis, any number can be selected. So you are free to choose any number here. What's the meaning of that? It means that the domain is all real number set or -infinity to +infinity. So domain is R, bolded R, representing -infinity to +infinity. Now that you have your domain, you can easily decide about your range. What is range? Range is the collection of y values. So what is range then? It says, well, I can freely select any value for x. And if I calculate that, I get some real numbers for y. Well, as you can take a look at your graph, the shade of this graph, if you look at the shade of this graph on y-axis, it covers everything on y-axis. If you just take a look at the shade, then what's the meaning of that? It means that, hey, everything on y-axis is acceptable, from -infinity to +infinity. So again, the range is the same as the domain, R or -infinity to +infinity. There you go. Another thing that we can talk about when we are graphing things is to use x-intercept, y-intercept. Okay, perfect. So 1.2, page 2 with example, and page 3 with the detailed definition. So intercepts. Intercepts are the points of intersection of the graph with x-axis with y-axis. We discussed this in previous session. So first of all, you have x-intercept. X-intercept is point that has first coordinate like x and second coordinate 0 is a point or points of the intersection between a graph and x-axis. To find x-intercept, as you can see, you set y equal to 0 and solve for x. To find x-intercept, we set y equal to 0 and solve for x. Other than x-intercept, we have y-intercept as well. Y-intercept. So y-intercept is a point or a collection of points like 0 and y, where the graph hits y-axis. Is a point or points like 0 and y, where the graph intersect y-axis. Well, to find y-intercept, we set x equal to 0, as you can see. To find the y-intercept, we set x equal to 0 and solve for y. Okay, you gave us the definition. What is the example? Example. Find the intercepts of this guy here. Y equals to x squared minus 2. So first, I'm going to find the x-intercept. To find the x-intercept, we set y equal to 0. So set y equal to 0, solve for x. So we are going back to algebra. Here you get 0 equals to x squared minus 2. So you add 2 to both sides, plus 2, plus 2. So x squared is equal to 2. So now to get rid of exponent 2, take radical. Take square root of both sides. So you get square root of x squared equals to square root of 2. Note the square root of x squared is equal to absolute value of x. We discussed this last time. So this is equal to absolute value of x. So here you get absolute value of x equals to square root of 2. What's the meaning of that? It means that the distance between x and 0 is equal to square root of 2. Well, you have some positive numbers, some negative numbers. The unit is the same. So x is square root of 2 and x is negative square root of 2. absolute value means the distance. So when we say that, hey, absolute value of x is equal to square root of 2, it means that the distance, the measurement from x to 0 is square root of 2 units. If you look at your x-axis, you have the 0, and then you have 1, and some negative numbers, some positive numbers on the both sides. Well, the distance from x to 0 is square root of 2. It means that that number can be positive, that number can be negative. We are measuring the distance. So that number can be here for square root of 2, and that number can be here, negative square root of 2. Both of them are absolutely acceptable. So we have two x-intercepts, x-intercepts, square root of 2 and 0, and the other guy is negative square root of 2 and 0. Now let us find the y-intercept. Y-intercept is easy. Set x equal to 0, solve for y. Well, x equal to 0, it means that I have y equals to 0 squared minus 2. 0 raised to the second power is just 0. So y is equal to 0 minus 2, or y is minus 2. What's the meaning of that? It means that your y-intercept is 0 and minus 2. This is your y-intercept. Let's take a look at this nose. Visualize this guy. And make sure that our intercepts are correct. So here you have y equals to x squared minus 2. As you can see, you have two x-intercepts, 1, 2, and you have one y-intercept, which is just right here. Okay. So this guy is an example of a quadratic function, and the graph that you just observed is called a parabola. So let us write down the general definition of a quadratic function. So definition of a quadratic function. A quadratic function is defined as, well, y equals to a, you have a number times x squared. This number is never 0. If it's 0, then you get a linear function. So a x squared plus b times x plus c. So a is non-zero coefficient. B can be any coefficient, can be any number. It's just a number. And C as well, it can be any number. Well, The highest exponent for x here is 2. Between 2 and 1, we say that, hey, 2 is the highest exponent. So the degree of a quadratic function or quadratic equation is 2, since x has exponent 2. So if you look at this example, this is an example of a quadratic function. Example of a quadratic function. Well, what is important about a quadratic function? It's important to know that, well, here this non-zero coefficient is called leading coefficient, and the behavior of the graph depends on A. The leading coefficient is A. If A is positive, then the general behavior of the graph is like this. We say that we have a convex graph, or it opens up. So convex graph. Convex or opens up. When you are working with applications, if you see a quadratic function, quadratic equation with leading coefficient positive, it means that you end up with a minimum for that question. So the minimum number of cells, the minimum wage, the minimum hours. However, if A is negative, then you get a concave shape. It opens down, and you end up with a maximum. So this is concave or opens down. As you can see, here the leading coefficient which is invisible. It is 1. So 1A is positive. And as we saw, this graph opens up. Very well. So we talked about a linear function. We talked about, well, a quadratic function. Let's write them down here. Then we define something that we call polynomials. As we increase the degree, we don't say that, hey, now we are working with, for example, just cubic function or function of degree 4 or function of degree 5. In general, we say that, hey, we have polynomials. So the very first function, the simplest function, is constant function. Y is equal to a constant like C. Then we have a linear function, which is y equals to mx plus b. Then we have quadratic function, which is y equals to ax squared plus bx plus c. Then we have polynomials in general. Polynomials. They have multiple terms. Here we represent them this way. We say that a is equal to an x to the n plus the rest of the terms. Many terms are involved here. Then a1 x to the first power plus a sub 0. This is called a polynomial function. For example, you have y equals to x to the fifth plus 3x squared plus 1. Or y is equal to 4x cubed plus 10. These are examples of polynomials. Well, these are nice functions. We are not really worried about these. These have domain and range well defined. We have some functions that we need to spend more time thinking about them. For example, absolute value function. Absolute value function. You're going to see all of these functions over and over again in calculus. So try to feel more comfortable about these basics as functions. So absolute value function is defined this way. We say that, hey, absolute value of x is equal to. Well, we're going to define something that we call piecewise defined function. It has two pieces. One piece is if this condition is true, if x is larger than or equal to 0, then this function, the y value of the function is equal to x. If x is negative, then the y value of the function is, it has a negative sign in front of it times x. So I'm going to use a different color to highlight this for you. Negative times x. So what's the meaning of that? If x in the domain is 0 or positive, then y value is equal to x. If x in the domain is negative, then y is equal to minus x. This is the interpretation of this mathematical form. And again, this guy is called, this is an example of a piecewise defined function. Piecewise defined. It means that it has different pieces. One piece is for positive part, one piece is for negative part. Okay, well, I expect you to ask, how do I graph this guy? Graph. Well, first of all, note that this function is defined like this. It means that we have to divide up the domain into two pieces. To graph this function, we need to divide up the domain into two pieces. One piece is for positive part of x and one piece for negative part of x, and 0 is also included. So here you have this guy. X-axis, y-axis. For x-axis and y-axis. Well, so for one piece, I have 0 and positive part. This part is x larger than or equal to 0. So how is the function? How is the y value defined on x larger than or equal to 0? It says, hey, y is equal to x. If I'm on this side, my y and x are all the same. So if I have, for example, 0 for x, my y is 0 as well. If I have 1 for x, my y is 1. 1 and 1. If x is 2, my y is 2. If x is 3, my y is 3. And note that you cannot go to negative part. you are strictly on positive part. So let us connect these two dots. What I get y equals to x on the right side. We cannot continue this line. We are not allowed to. We cannot go here because it says this strictly for x larger than or equal to 0. So let us take a look at the second piece. It says, hey, if x is negative, you get minus x as your y. So on the negative part of x-axis, your y is equal to negative x. Okay, let's take a look at this. On the negative side of x-axis, which is on the left-hand side, x is negative, y is equal to minus x. So if I plug in, for example, my x is negative. Negative 1, I get negative times negative 1, which is positive 1. So if x is negative 1, my y is positive 1. If my x is negative 2, my y is positive 2. And continue. So if you connect these 2 points, you get the second piece of your graph, which is a V-shape, absolute value V-shape. So this part is y equals to minus x on the left. One more example about your absolute value. So suppose I ask you to sketch the graph of y equals to absolute value of x minus 1. So, example. This is your 1.2. You are on page 5. So graph y equals to absolute value of x minus 1. Very well. So recall that for your absolute value function, you have this case. If you have just absolute value of x is defined as if x is larger than equal to 0, your y value is x. If x is less than 0, you get minus x. Here you have x minus 1. Well, how do I decide about the conditions? What you're going to do, you're going to take this quantity based on the definition of absolute value. Remember that when you're talking about absolute value, if that quantity is larger than equal to 0, you get that quantity back. If that quantity is less than 0, you get minus times that quantity. So in general, you can define your absolute value function this way. You can say that the absolute value of quantity like p of x is defined this way. So if that quantity is larger than equal to 0, I get that quantity back. All right, whatever it is. If that quantity is less than 0, I get minus times that quantity. So we just generalize the idea of absolute value into any quantity. Instead of having just x, you can take, hey, I have, for example, x minus 1 as that quantity. So this is equal to, well, this is my quantity, x minus 1. This is the quantity that I have. So if this quantity is larger than equal to 0, what's the meaning of that? It means that if x minus 1 is larger than equal to 0, what I get this quantity back, x minus 1. If this quantity is less than 0, then I get minus times the quantity, which is x minus 1. So let us go back to algebra, simplify the whole thing. So y is equal to, if I add 1 to both sides, I get if x is larger than equals to 1, I get this linear function, x minus 1. If you add 1 to both sides, it means that if x is less than 1, then I get minus of this quantity. If you distribute negative sign into parentheses, you get negative x plus 1. So for y equals to absolute value x minus 1, we interpret that on the domain when x is larger than equals to 1, y, the output value, is equal to line x minus 1. And on the domain when x is less than 1, then y is equal to 1 minus x. Increasing line, decreasing line. That's how you get the V shape. So let's graph it. This is my x-axis. This is my y-axis. So note that your focus is on 1. So you need to find 1. Where is 1? 1 is here on the right-hand side of x-axis. On the right-hand side of 1, x is larger than or equal to 1. What is your y? Y is x minus 1. So if I plug in 1 here, I get 0. If I plug in, for example, 2 here, I get 1 back. So if I connect these 2 points, I have some part of the line y equals to x minus 1 that I'm allowed to define on x larger than equals to 1. What about on the left-hand side? It says when x is less than 1. Less than 1, this guy is just right here on the left-hand side of 1. So my y is defined as 1 minus x, the decreasing line. So if I plug in, for example, here 0, if I plug in 0 here, y is equal to 1 minus 0 or just 1. If I plug in negative 1, I get 1 minus minus 1 or 1 plus 1 or 2. If I connect these points together, what I get y equals to 1 minus x. So this is the graph of this function. So is piecewise defined function only defines for absolute value? Of course not. You can define piecewise defined function yourself. For example, you can say that, well, out of nowhere, out of my imagination, I want to write down one piecewise defined function. Just for having fun, nothing else. The following are examples of piecewise defined functions. Well, the first one, to define this function this way, you would like to say that, hey, if x is larger than or equal to 0, I want it to have a parabola shape, x squared. And if not, if x is less than 0, I want it to have a linear shape. Like what? Minus x. How do you graph it? Not that hard. So based on the definition, if x is larger than or equal to 0, it means that I'm here. And what's the graph like? It's x squared. It means that I have a parabola. Since the leading coefficient is 1, it opens up and the graph behaves like this. x squared. Well, if x is less than 0, then I have a linear function. Okay, where is less than 0? Less than 0 is on the other side. Here. What do I have? I have a line decreasing. Okay, if x is -1, I get 1 back. So if I connect this way, this is your line, y equals to -x. Another one, you can define y to be equals to, let's see, if x is larger than -1, I want it to be, for example, let's see, 2x, okay, line. If x is exactly -1, I want this guy to be, for example, 2, 3, 4, let's say 4. And if x is less than -1, I want this guy to be, let's see, something else, -x squared. Out of nowhere, just using your imagination, having fun with functions. So this function has 3 pieces. One piece is linear, one piece is constant, one piece is quadratic. So let's graph this guy. It says, well, if x is larger than -1, larger than -1, there is -1. -1 is just right here. Larger than -1. What do I have? I have 2x. 2x, if I plug in, for example, let's see, 0, what do I get? I get 0. If I plug in -1, I get -1. If I plug in, for example, 1, I get 2, and we can continue this process. If x is -1, I get 4 back, and if x is less than -1, I get this function flipped back. Okay, 2x, let's see. And here I have this guy. So at this point, it's going to be -1, -2. So let's move this a little bit further here, and 0, and then it's going this way. So this is y equals to 2x. At -1, I have 4. So 4 is here. So this is my 4. And when x is less than -1, I get -x squared. -x squared. -x squared. Well, here we know that x squared passes through this way. So some part of it is going to be like this. Not this part, it's just going to be this way a little bit. My graph is not very accurate, but yeah, that's good. And this is y equals to 4. Well, this is your graph. Crazy looking graph. Doesn't make any sense, but this is coming from our fun, our imagination using piecewise defined function. Let us think about the definition of a circle and try to use the definition of distance that we learned before to write it mathematically, to model it mathematically. So first of all, recall that if you have 2 points for 2 points, like x1, y1, and x2, y2, the distance is defined this way. So the distance d is equal to square root of x1 minus x2, or x2 minus x1 squared plus y2 minus y1 squared. This is the definition of distance that we discussed before. Now, what is a circle? Definition of a circle. A circle is a set of points. So what's the meaning of that? It means that a circle is a relation. We just learned about the relation. So a circle is a relation. For these points, they have the exact same distance from a fixed point that we call the center. these points have the same distance from a fixed point that we call the center. So let us use the definition of the distance, because we're using the distance here to define the circle. So what we're going to do, we're going to fix a point like h and k for the center. Let us fix a point like h and k as the center. Okay, I have h and k. My first coordinate is h, my second coordinate is k. Let us take a random point. Take a random point like what? X and y. Okay, I'm allowed to do that, of course. A point, X and y. So what is the distance between them? The distance between them, I can easily write that distance d. The distance between them is d equals to square root of, well, here I have x minus h squared plus y minus k squared. Okay. But remember that when we talk about a circle, we call this distance the radius. So it means that r is equal to square root of x minus h squared plus y minus k squared. You can raise both sides to the second power to get rid of this radical. Raise to the second, and what do we get? We get the equation of a circle with a radius r and the distance and the center. The radius and distance are the same. The center h and k as r squared equals to x minus h squared plus y minus k squared. That's how we officially define a circle using the distance formula. If you continue taking other random points, x and y, then you can connect these together and actually define your circle. Okay, a couple of examples, then group activity. So suppose this relation is given to you. Example. What is the center and radius of the following? You get x plus 1 squared plus y minus 2 squared equals to 20. So you have a definition, guys. try to compare it with the definition that you have. The definition says, hey, you must have x minus a number, whatever that number is, it's 0, is it positive, is it negative, to the power 2, plus another quantity, which is y minus another number raised to the second power equals to r squared. So we need to see this exponent here. So do I have x? Yes, I have x. Do I have a minus sign? I don't have a minus sign. So what should I do? I should convert this plus sign into minus sign. But how do I do that? Well, plus sign is minus times minus. So it was originally x minus -1. It wasn't a positive number originally. It was a negative number. So now I have my x, I have the minus sign, and I have my h, which is a negative number. Okay. Plus, here I have y. Yes, of course I have y. Do I have a negative sign? Yes, I see a negative sign. Do I have a number? Yes, I have that number to the power 2. So far I'm good here for the second quantity. Y and y, negative and negative, k and 2. So what do I see here? Do I see exponent 2? Of course not. I only see 20 here. So what's the meaning of that? How can I create exponent 2? I can write this as square root of 20 raised to the power 2. Remember that square root and 2, exponent 2, they cancel out each other. It means that you get your 20 back. So now I have r, which is square root of 20, and the exponent 2. So h and k, h is -1, k is 2, and r is square root of 220. So you have a circle with center at -1 and 2 with the radius square root of 20. So if you want to visualize this guy, here you have -1 and 2. -1 and 2 is the center of your circle, h and k. So your circle is located here, and square root of 20, well, it's 4 point something. Well, it means that your graph should be like this. This is your circle. So this is the center, -1 and 2, with radius square root of 20.